Assalamualaikum ma'am. This is Anam here, and I would like to present the presentation of my project credit card fraud detection using machine learning. The objective of this project is to build a machine learning model that can identify whether a credit card transaction is fraudulent or legitimate. Fraud detection is an important real world application because financial institutions lost millions of dollars due to fraudulent transactions everywhere. Since fraud cases are rare, this every year becomes a challenging machine learning problem. Here first I would like to import libraries, that is Panda, NumPy, Matplotlib, Seaborn, and why I would like to import these libraries. Panda is used for loading and manipulating datasets. NumPy is used for mathematical and numerical operations. Matplotlib and Seaborn library is used for data visualization, and the other one scikit-learn libraries are used for pre-processing, model trainings, and evaluations. For machine learning libraries save time because they provide optimized implementation of algorithm. Afterwards, uh, afterwards I load the dataset to Panda data frame. And why did I perform this step? Understand the structure of dataset, verify that the data loaded correctly, observe the features correctly, and the dataset contains time v1 to v28 features, amount, class, which um I mentioned here. The first one is time, and v1 to v28 are features, amount, and the last one is class. And the targeted value uh, is class 0 for legitimate transaction and class 1 for fraudulent transactions. Afterwards, the understanding of dataset informations. First, this is a head, and the whole portion I cover, and the credit card tail, the last 5 rows. In tail, the last 5 rows are shown here, and in head the first rows are shown here. And dataset information, why the function tell us the number of rows and the number of columns, data types of each feature, missing values, and understanding the dataset before training is extremely important because machine learning algorithms require clean and consistent data. Afterwards, step 4 was checking the missing values and why missing values can reduce the model performance and even cause some algorithms to fail. Fortunately, our dataset contains no missing values, so no imputation was required. And afterwards, checking the class distribution. Why I would like to tell you that this step helps to determine whether the dataset is balanced or imbalanced. The dataset is highly imbalanced. Legitimate transactions are very high and the fraud transactions are very few. This balance can cause the model to predict everything as legitimate and still achieve high accuracy. Therefore, handling imbalance becomes necessary. 0 for normal transactions and 1 for fraudulent transactions. And the next step is separating fraud and legit transactions. Why? Because I separated both classes to analyze them, and analyze them independently, and prepare balanced data. This allows us to understand how fraud transactions differ from normal transactions. And the second next step is statistical analysis. Statistical analysis, why this provide mean, standard deviation, minimum, maximum, and quartiles. This helps identify differences in transactions amounts between fraud and normal transactions. And the next step is group analysis. In group analysis, this compares average value of all features between both classes, and if features distributions are different, then machine learning algorithms can learn patterns to distinguish fraud from legitimate transactions. And in our next step, handling imbalanced data using undersampling. Why? Because the data set is highly imbalanced. If we train directly, the model will become biased towards legitimate transactions. Therefore, I used undersampling, where 492 legitimate transactions were selected and all 492 fraud transactions were retained. The new dataset become balanced. And in our next step, verifying balance. Class 0 is equals to y to confirm class 0 is 492 and for class 1 is equals to 492. Here it is. Balanced data allow the model to learn both classes equally. And in our next step, feature and transaction separations. And in features and transaction separations, x equals to new dataset dot drop and y is equals to new dataset class. Why? Because machine learning algorithms require input features x and output labels y. Here x is equals to transaction information and y is equals to fraud or non-fraud. Afterwards, I split the dataset dataset into training data and testing data. Okay, why? Because 80% training data and the 20% is testing data, and its stratify is equals to y, maintain equal class distribution in training and testing data. Random state is equals to 2 ensures reproducibility. And in our next step, model training using logistic regression. In our model training logistic regression, why did I choose logistic regression? Because it performs well on binary classification, easy to interpret, fast training, serve as a good baseline model, and the model learns the relationship between transaction features and fraud labels. And in our next step, training accuracy, here it is. Why? Because training accuracy tells us how well the model learns patterns from learning data. Okay, and accuracy on testing data, or we can say our testing accuracy. And why I perform testing accuracy? Because testing accuracy measures the model's ability to generate to unseen data. This is more important than training accuracy. Here comes to our next step, which is data visualization. And in our data visualization, this shows the data visualization of count plot. In our count plot, Y to visualize class imbalance. This is a count plot of class imbalance, of showing class imbalance. And here comes to our next step, which is a correlation heat map. And in our correlation heat map, this is the coding, and in Y I implement correlation heat map to observe the relationship between variables which is highly correlated features and can influence model performance. And this is the illustration of heat map. Afterwards I apply histogram. And why? Because to understand the distribution of transaction amounts. And then come towards our feature scaling. And why I use feature scaling? Because different features have different ranges, and which shows that mean is equals to 0 and standard deviation equals to 1. This improves algorithm performance. In our next step, training multiple models. I also train logistic regression, which is simple and interpretable. And in our second model, which is random forest, combines many decision trees and handle complex patterns. Afterwards I apply XGBoost, one of the most powerful boosting algorithm. And AdaBoost आपके पास हाँ. Then afterwards I apply AdaBoost, and AdaBoost focus on correlating previous errors. And why train multiple models? Because one algorithm may outperform others, and comparing models help identify the best performing classifiers. And in our, I guess, last step, evaluation matrix. In our evaluation matrix, I use accuracy, precision, recall, F1 score. Why not rely only on accuracy? Because fraud transactions is an imbalanced classification problem, and matrices like recall, and the second one is F1 score. It provides a better evaluation. That is the main reason I apply F1 score and recall other than just accuracy. And afterwards here comes to a confusion matrix that shows how many are true positives, true negatives, false positive and false negative. This is the illustration of true positive, true negatives, and false positive and false negative, that gives a detailed understanding of model performance. Okay, I apply the ROC curve which shows to measure the trade-off between true positive rate and the false positive rate. A higher AUC value indicates a better model, which is around AUC equals to around 96. And then comes towards the small smart. Why I apply smart? That creates a synthetic minority samples instead of deleting majority data. This is often improves fraud detection performance. Then apply uh, hyperparameter tuning. In hyperparameter tuning, grid search CV is used. और I guess स्क्रोलिंग में कुछ थोड़ा सा इशू हो रहा है. This is grid search CV, and in grid search CV, because why I use, because machine learning models contain parameters that affect performance, and grid search automatically finds the best combination of parameters, and afterwards I use important features, or why I use to identify, because features contribute most of fraud predictions, and this improves the model interpretability. And the final conclusion is that this project successfully developed a machine learning system capable of detecting fraudulent credit card transactions. The major step is to understand the data, then to clean the data, and handling class imbalance, data visualizations, feature scaling, and train the model and evaluate the model, apply hyperparameter tunings, and afterwards the last feature important analysis. Thank you so much.